This is a continuation of the previous recording on the member functions or methods of cout object. The focus of this recording is setf and unsetf function, where we will learn about using these functions to set and unset iOS flags. This allows us to manipulate alignment of the printed data, display format for floating point numbers, fixed or scientific display, display format of integer number, that is hexadecimal, octal or decimal, and more. I am starting off with this code. This is the code I obtained at the end of previous recording, part 1 of this topic, cout object functions. That was the title. Previous video part 1 will help you understand this code better. Let me quickly explain it anyways. This is a structure to hold ID, name, number of marks and marks of a student. This is an array with two objects with data initialized. This is logic to compute maximum number of marks. 2, 1. Out of 2 and 1 it will compute 2, and which is used in the code. Now this code displays the data in this format. So this is the output of output, and we have the header line, title row of the table, and the data row of the table, two data rows. Now this part of the code is to display the title row, ID, name, number of marks, and this is the loop which will iterate to and display the first row and second row in its first and second iteration. Here I will actually demonstrate the use of these following functions that you can use with cout, setf. This is for setting flags, and another unsetf for unsetting or for reversing the action of setf. There are different flags that you can set and unset using these functions. Uh, first, I would like to discuss about this flag, std iOS left and std iOS right, and next std iOS we have fixed, scientific, std iOS decimal. This is for decimal, hexadecimal. All these are the flags for manipulating the output, the way the data would be displayed. This left and right is for left alignment, aligning the display in the left side and the right side. Fixed and scientific is for putting out or displaying the floating point number either in the fixed point format or scientific format. DEC, hex, and OCT, I think this is OCT. OCT are for displaying the data in this corresponding format, either decimal or hex or hexadecimal. So first I will demonstrate the use of these two functions with left and right. So what I plan to do here is, so here this name is actually placed in this entire field uh, towards the right side. This is by default, it is aligned to the right side. We can make it display on the left side of this field, or similarly you can also do the same for the marks. You can do same for the name. In this case, entire field is occupied by this name, but in the second case, this is not occupied, so you can make it align to the left side. Number of marks is also aligned to the right side. You can make it align to the left side. So let us do that. So to align the name, this is the cout statement that displays the name. To align the name on the left side, what I would do is, just before we display, I invoke setf function and I pass the flag into it, left. And this once you set this align to the left, then this will not only apply to name, it will also apply to other um, data items that are put out. So I would actually, after setting this to the left side, I also want to undo the left setting, because otherwise if I this name will be aligned left, then that will actually I mean this effect will also apply to other fields that would be displayed. So I if I want to apply this field only selectively to one particular data item that is put out, then I need to actually unsetf. So it will reverse that setting action that was done by this line. Similarly, if I want to do the same for the marks, and you unsetf, and inside the name, we also have the name in the table. So we also also want to align to the left side, and I will leave this for the exercise for the viewers. So this is the name I want to align to the left, and we have so let me switch to the terminal and try to do the compilation again and execute and see the output. Now you can see the name is aligned to the left side here, unlike in this case, and the marks is also aligned to the left. The name the name content is also aligned to the left. This is exactly what we expected. In addition to left, you can also align to the right. Many times by default it is aligned to the right side, so you don't need to do that, but sometimes if you align to the left side and even reverse, then you can also use the right flag to reverse it. Next thing I want to demonstrate here is this fixed and scientific. If we look into the output, this data is actually displayed in the fixed point format. This is a compiler actually program automatically determines whether to display in the fixed point format or the scientific format, depending on the type of the data you enter. Right, this is all these three floating point data are actually displayed in the fixed point format. For example, if I go back and make change to the data. Let's say this 6, try to make it a bit bigger. Let's say 666, right? So if I have this data here, then I want to see whether compiler actually makes a decision to display in another format. Now you can see this is the scientific format in which that data has been displayed. So compiler had decided it. We didn't decide, compiler or the program itself decided it. Now I will show you how you can enforce the fixed point format. I didn't want that scientific format to be used, to be applied. I want to actually force the fixed format. This is the statement that actually displays the marks. So if you want to force the fixed format display, again use setf function, fixed flag, and once you use it, make sure that you unsetf afterwards. So with this change, we should see the data, all the data displayed in the fixed point format. Compilation and linking, execution. No, you can see this is not a scientific format anymore. It is a fixed point format, right? Similarly, if you want to enforce it to be displayed in scientific format, then instead of fixed, you can set the scientific flag. So I would use scientific, and you also unset it. With this change, we will see the following output. So now you can see all the data, all the marks are displayed in scientific format. This is the same marks, but only the format display is different. Now finally I will discuss, I'll talk how to use these things here, this how to set make use of this flags. I choose this data to demonstrate the use of this ID to demonstrate the use of this hexadecimal, octal and decimal display. This is actually the decimal display because the ID is set decimal value 101 to 21002. These are decimal values. If you want to display this in hexadecimal, then I would do something like this. This is the ID. So I would set the flag hex. So here, if you set this flag, then it will also, come as a mix of decimal, because default decimal flag. So if you want this to function properly, you need to also unsetf something called base field, right? So first you unset the base field and then set to the hexadecimal. Then we will be able to see the number, the data in an ID in the hexadecimal format. So we have the data displayed in this format, and with this change, You can see this 101 is display 65, which is hexadecimal form of 101, and in hexadecimal 21002 will look like 2520A. This is the hexadecimal display. And if you want to display as an octal number, then you can set as a OCT. So this is the octal version for this same number 101 145. So 21002 is 51012. So for the rest, yeah, I encourage you to practice playing around with this function, setf, unsetf, and the different flags. This is all I have to talk about this topic on this recording. Thank you for watching.